actually, we'll say the president of the ATI branch.
Wow.
So let me go ahead and hop on over here. What wasn't labeled on the first one was that I did my second internship for ATI Cast Products down in Albany. It was a difficult experience, but overall very beneficial. So a little history about the company. It started out in 1968, owned by Tie-Line, and by then it was a graphite sand factory. 1971, Whitaker purchased it and expanded facilities. I'm going to kind of fly through this because it changed hands so many times, it's almost confusing. In 1986, Tie-Line Inc. Purchased by Ruger, the same the firearm company, and ESCO relaunched and turned it into an investment casting. How many of you guys know what investment casting is? All right. We'll kind of go over that a little bit more later. In 1991, it merged with Titech. 96 was purchased by Tymet. In 2000, purchased by Laddish Company and renamed Pacific Casting Technologies. In 2011, it was purchased by ATI and renamed ATI Pacific Cast Products. A little back history, I know not such a sport, but the reason that ATI purchased it in 2011, that factory was actually being bought by PCC, Precision Cast Parts. And if Precision Cast Parts owned that facility, they would have a monopoly on titanium casting processes. All their customers didn't like that. So
the government stepped in and saying,
more or less stepped in and said, no, you can't do that. So ATI bought them. And just recently, it was renamed ATI Cast Products.
Anti-competitive laws.
Yep. So about the work, I put hourly pay. I was getting paid $20.64 an hour. I averaged 40 hours a week. Worked Monday through Fridays. Originally, I started out, 7:30 to 5 o'clock every day. Had a half an hour paid lunch. I ended up changing those, so I was coming in about 6:15 and leaving earlier. Main reason for that was I live in Sandy. My job was in Albany.
Yeah.
So it was a
Take Highway 22 across Salem, or take 99 across Salem.
It was listen, put it this way. I could get to work in an hour and a half. Traffic was light. Coming back, it was an hour and 45 minutes. Yeah, it was
3 hours driving a day.
So I didn't always have to travel to and from. I had friends that lived in Monmouth that let me stay there during the week, and on the weekends I went home to be with my family. I had the opportunity to do overtime. That's when I'd come in even earlier and then stay maybe an hour later. Just more time at the computer. Benefits, kind of. I guess you might say the benefits packages like insurance and things like that, they're not going to offer you that. And let's say I didn't get paid holidays, but they offered me the overtime to compensate for that. They did give a nice yearly boot allowance. I got a pair of really nice boots, and they gave me a $100 voucher toward those. So it was very, very handy. All right. Here's the structure. I'm not over here. I'm right down the middle. So I was part of the expansion team. More or less, that whole part of the company dealt with expanding the manufacturing capabilities. So I was really excited to join that because one of the things that I enjoy doing is lean manufacturing, applying lean manufacturing. I find it fascinating. I love it. So I was really, really happy to be in there because one of the things that I asked, and maybe you guys don't know this, you guys have had your first initial interview with me, Cobb. when you actually have your placement interview, it's going to be very similar to that interview. Some of them are going to ask you, what your interests are. Be honest. Both my internships, I was honest on what I wanted to do, and I got to do projects based on that. So definitely be honest. All right, department interactions. There's a lot of departments when it comes to invest casting foundry. Had to deal with wax, knockout, maintenance, salvage, process engineering foundry, inspection, continuous improvement, purchasing, expansion team, invest. Each one of these areas has their own, separate thing, but some of my projects encompassed all of them. If there was information that I needed, I typically knew where to find it. So interaction with all of those was very crucial. All these department managers, even down to the individual workers, was very crucial. So that definitely would have built good relationships with everybody. So here's a list of the main projects. Lean simulation project, knockout water blaster upgrade. That was kind of a, I'm going to call it an attaboy thing, like, hey, let's give them a quick win. Improved metal control project and mold cooling project. It says not included, mostly because that project, I got halfway through it and the company decided to put a bigger team together and take my project and put it on steroids. And it really moved it out of the scope of my project. So they asked if I could share the information that I have and then move on. So I was more than happy to help if they ever needed it. All right, Lean simulation project. Have you got any of you heard of a software called ProModel? Good, you guys don't have headaches yet. It is a very complicated piece of software. More or less, what you could do is map a process in a digital environment. So these are actual maps, and you give it inputs. Feed rates, how often are they coming in, how many are coming in, process times for each station. Everything. You can get really, really specific about it. And when you hit that little green go button, it will send those parts, like as you can see right here, this little blue dot. Imagine a blue dot going from here, waiting a specific amount of time, going to the next one, going to the next one, and it just moves around. So a lot of bright, flashy things moving. Then it spits you out an output. And it'll tell you how many parts you can average, per month, max, min, all of it. So my job was to map all of the areas, all of the departments in the entire foundry, pretty much. I looked at it as it was my major project. It was, for me, difficult. I'll kind of get to what made it difficult toward the end, kind of summing everything up, but it involved a lot of computer programming. Not a strong suit of mine. So it took me and 3 other engineers, plus a consultant from ProModel, working on this to get it mostly done. It took quite a bit of time. So the main challenges were learning a computer language, getting and organizing good data, because you could get data, but it may not be good data. So you have to sit there and vet it out, make sure that verify it before you can put it in. And then, of course, scheduling time with my lean simulation team, because they, like in that presentation, other engineers have other projects that are really important to them, and it's really difficult to find holes in their schedule to get them to join your project. So the results, 4 or 5 departments were modeled. I finished comparative analysis on each. Each analysis was compared to available capacity models that were already developed by the team, but it was spreadsheet driven, whereas Pro Model is not spreadsheet driven necessarily, because you could enter in things to make it more accurate. And the models are supposed to be used in further expansion team projects. Instead of saying, writing things out by hand and saying, hey, this is what we want to do, and according to our calculations, we should be able to, have this output and go with that. What if they spent some time and modeled it, and then they added in these different variables into there and see what kind of changes they were going to get? It saves them a lot of money. Okay, so the Knockout Water Blaster. The water blaster is a large vessel, has an arm in there that holds these titanium parts that still have an investment slurry on them, or it's the casting shell. We got to get that off. So one of the things that they do is they dip it in a caustic material substance, has a lot of acids and things in it, and it gets most of the big stuff off of that titanium casting. After that, it gets loaded into this vessel, and it has a 16,000 PSI water blaster shooting this thing. Well, we were having problems with the water blaster because, you got this vessel and you got a little window you're looking through with a big pressure washer, essentially. So when this thing's going, the water's heated also. As soon as you pull that trigger, everything steams up. You can't see hardly anything, but you know that you're removing material, because even in a wet environment, titanium, if something strikes it that is not water, it'll still spark. So the operators, because of this, water splashing back in the little face shield area, they were sitting like this, holding on to the control so they can manipulate the part, and the water blaster and the trigger's down here. So they worked like this for 8 hours. How many of you are saying my back already? I really felt for them. So at first I thought, hey, let's make the wand more movable, and let's just make it so they get to these areas easier and be able to stand up. Just move the wand. Make it easy. But that was me just jumping into solution mode. That's not what they needed. They'd still be back in that same situation, because the root cause of the problem was the excessive buildup of steam. They were looking through this much of the window. The window's this big, and they were looking through this little spot just to get underneath the steam so they could see. So finding this root cause was spending a lot of time with the operators and observing and just listening to them. So the overall change was I needed to reduce steam. I looked at what they had, and this, I don't know if you can see it. Can you see this picture right here? Yeah, it's a giant fan. That's a circulation fan. Okay, a circulation fan pulls air from around it. So that was set on top of the exhaust vent to pull the steam out. Well, most of the air it's pulling is from outside the vessel. That's not helping. Well, sorry, it's helping a little bit. So my idea was, let's put an induct fan over the top of it with a chimney and what they call a China hat. And at that point, it's only pulling air from the vessel. So I got a fan that pulls 4,600 CFM. Industrial, yeah, an industrial, all stainless steel built, anti-corrosion fan. Yeah, it's caustic material. Putting just a galvanized steel in there probably wouldn't last too long.
Oh, because you got the steam plus the titanium with whatever acids and stuff are still on it.
Yep, that caustic material. The reason for the chimney was some of this caustic water from the steam, because it was just venting out into the room, was actually dripping onto the operators. Yeah.
Acid rain.
Acid rain, exactly. So here's a rough sketch. One thing I didn't have access to in my second internship, and I wish I did, was solid modeling software. I'm pretty good at using SolidWorks. So I would have loved to have SolidWorks. I would have modeled the entire vessel, put that on top of it, you know, basically said, here you go, this is what I want to do, and here's how it's dimensioned and everything. It would just been one great big beautiful package, and here you go.
Very expensive though. How are you gonna have access to that?
My first internship, I was using SolidWorks every single day.
Well, yeah, companies have it, but it's like 30 grand.
Right, but I was working for a company, so it would have been nice if I had access to it, but
Use an Autodesk product like 360 Fusion to do the same thing. Or Inventor.
they're using something very similar to Inventor. But here's a picture of one of the operators while he's working. You see how he's bent over? Yeah. Not good. So the challenges, we're finding the time and spending the time to find the root cause. Working around the water blaster was difficult because I'm an engineer. I've got my safety glasses on, but you're working around things that are hazardous. So you only walk around that water blaster when it's okay, and you just have to be able to once you get down there and spend time down there, you realize, okay, I'm not supposed to be here, so come back later. Getting design approval, I had to get approval from the department manager as well as the shift lead and my mentor, and that proved to be a bit of a challenge because you have to get everybody on board, and after that you got to find out what department do I go to have this built. And of course, communication between department. The implementation when I left was in progress. In reality, I had this thing dialed and set, ready to go about halfway through my internship. My mentor decided to take a 1-month vacation in Italy. He deserved it. He works a lot. But other departments really wanted my mentor's buy-in, which I tried to communicate that to them. But like I said, communication is very key. I don't want to badmouth them because I like the people who work there. I really do. So the implementation process was being done when I was leaving. Improvements were the lighting. One thing I failed to mention, I did add an extra floodlight in the back of the vessel to flood the area with more light. Improved the ergonomics for the operators, and as a bonus, it decreased their cycle time on their large parts by 15 minutes. That's a bonus. So overall, increased throughput. Metal control. These are actual parts, 1717, 1732s. If you can imagine what these parts are, how many of you have ridden on an airplane? Okay, our parts are on there. They're on the engines. That's what ATI builds, engine components for the jet engines. So the problems were these large parts, there's too much variation in the pour weights. Now, the whole pour process with the furnaces that we use, they are vacuum furnaces. They have to be, because titanium, when it is molten, if you add oxygen to it, it's explosive. Yeah, you start a titanium fire, hopefully you have the equipment to put it out, because if not, you just sit there and watch the entire building burn. So finding these variations proved to be very difficult. You know, was it cooling? Is there fluctuation in the power? You know, as it ramps up and starts, creating an arc that's melting a titanium billet. There was just so many variations that could be thrown in there, and it was hard to track them. So the problem was those variations, trying to find the root cause, reduce the variation, and then from there you can tighten up your pour weights or your pour times. So what I was able to do is I calculated collected some sample data, a lot of sample data. Examples like mold weights going in and out of the furnace, the freeboard weight. The freeboard weight is the large cups that sit on top of the molds. The amount of metal that is measured from the top of the cup to where the metal actually is. That's your freeboard. And we want to take that amount that was in that cup and reduce it. We couldn't take it all away because the knockout department would use the excess cup to grab a hold of and move the part around. So we had to keep some of that in there. Apply the statistical analysis to the 1732s and 1717s. Even after changing some things, the variation was just too wide. And I wasn't able to propose any changes. Everything, the bell curve was just way too wide, too much variation. I did approach the idea of putting load cells inside the furnace so people could so you would actually know, variation or not, exactly how much weight is being melted in that crucible. And from there, you can find out how much you're pouring into your mold. But that was a $200,000 upgrade to the furnace.
That may or may not solve the problem.
May or may not. But one of the things that we do know, our competitors, PCC, we knew that they use load cells on their furnaces.
They still have the same variation problem?
Nope. So the challenges was collecting data exactly how I wanted it. I had to be there with the operators to tell them, hey, this is what I need. This is exactly what I need. And if they went to do something that would give me some variation or unexplained variation, I had to be there to, kind of tell them, hey, we can't do this because of this. So a lot of interaction with the furnace operators. Another problem was finding parts that were being consistently run. Some of the parts, we'll do 7 or 8 of them a day. Others will do 1, maybe even 3, maybe 2 or 3 a week. So it's very difficult to find, to build a 30-piece sample. So
it's not like a 3D printer?
Nope. Nope. If they could 3D print titanium, well, they would have to have it in an argon environment.
So everything would basically just be a weld.
Yes, everything would have to be a weld. So more or less, it was determined that more data was needed to be collected before the pour process could be reduced. The project was handed over to a new hire. Her name was Karen Corliss. And her job was to do a long-term analysis on that. So I got a chance to work with her and pretty much package everything up, everything that I did, and hand it off to her. So what I learned, improved skills in statistical analysis, questioning data. I mean, a lot of times in the classroom, we're just given data. And typically it's verified. Sometimes we're not taught to verify. Verify your data. Again, sorting good data from bad data, working with multiple departments. I enjoy working in a team situation. I like communicating with people, learning about people. I typically don't have problems with people, typically don't. Better time management. That is definitely key. Manage your time. And of course, when presenting proposals and everything, speaking with data. That was my mentor's name is Al Wentland, and that's how he was. He's like, he would always tell me, "Show me the data. Show me the data." So I learned to speak with him with data. Useful classes, technical report writing, definitely. Engineering computation, for that one. I mean, I took the class 2 years prior, so I really had to dig up the things that I learned at one point in time and apply them. Public speaking, small group and team communication, manufacturing, analysis and planning, statistical methods 1 and 2, definitely. And then I added in some GD&T and statistical methods for quality improvement. All definitely helpful classes, especially for statistics. You may not be able to tell what test you need to run, but there's resources out there that'll help you with that. But as long as you understand, the fundamentals of it and apply them, definitely helps. Do you have any questions? Any whatsoever about my?
How precision? How close to, like, how small are some of these pieces that you guys are making? Like how precise are you?
Some of the pieces are this big.
Okay, so but they're not like little tiny screws that go in your leg for, like that kind of titanium.
He's doing aircraft stuff.
Yeah, this is aerospace mostly.
So aerospace, but precision, pretty precision.
Yes. Once
are just all molded. No, but
these are all casting, and then the parts get taken to their different departments and their process. Some of them, some of the molds will have a bunch of little pieces on them, but it'll be one mold. I think one of them was at like 272 parts on one mold.
Oh wow!
And so there was some pretty small parts.
Where do you guys get your molds?
The molds, we make them.
What do you make the molds?
But do you make them with
Business molds?
CNCs and stuff like that?
Nope.
Like what? Like are you melting? Like shaping them with what? What are you shaping them with?
Investment casting is done using wax.
Okay.
So we have these large dies, and they start out with nothing in them. We put them in our wax injection presses, and they inject them full of wax. They let them cool. They let them cool a little bit, break them out, and then they're handed over to a wax assembler, and they'll take different pieces of wax, different parts that were already molded, and they'll seam them together and to make one big
How are
part.
they molding this wax? With what? Like what are
With
they
a die.
cutting with? Okay, so they're making it with a die.
Yeah, the dies are typically supplied to us from
Somebody else.
the company that wants them.
And then do you still work there?
No.
Now, did you ever want to go back into that, or did you want to go to Precision Cast Parts or somewhere like that?
Would I mind doing that as a job? I wouldn't mind. For PCC, I probably wouldn't mind that because it's a lot closer to where I live right now. But overall, I like I said, I don't think that that area of the company is what I would want to work in. I might actually, I think I'd actually enjoy working in the engineering department. My project was more project management based. So I got to say, so the project management part gave me something that I really haven't had an opportunity to learn here yet. So the project management side is definitely helped me understand lead times and being able to plan things so that you could stay on task.
So you're manufacturing?
Yes.
So when you start your internship, like when you walk in the company, do they give you like project right away, or do you have to like find your own like?
If I could put it delicately, they're bringing you in as an intern, but I think most, at least the 2 internships that I took, they assume that I don't know anything. So they do give me credit that I am a college student, but they don't say like, here's your projects, bye. So you don't just sit there like, oh my gosh, what do I do? What do I do? Most companies will train you that first month, so you get an idea of who's who. Where can I go for this information? So none of the companies that I worked for just left me floundering. Let's put it that way.
So it's more like being a new hire.
It is very similar to being a new hire. All the my first internship was with Blunt International. I went through all the same orientation stuff that the new hires went through. One of the things that mentioned, I was talking with the CEO of Blunt International, and he said one of the things that they wanted to do was get the new hires involved in Kaizen events. So they knew what, how things worked at that company. So I got to be in a Kaizen event on my internship. Very beneficial. Very beneficial. Really enjoyed working with a group of engineers, machinists. It was a lot of fun. Made a lot of good friends.
What's a Kaizen event?
Kaizen event. Kaizen stands for continuous improvement, or to improve upon in Japanese. So basically you're working with people from a specific department, and they have a problem and they're going to try and fix it. So that most companies have a Kaizen team or something like that, or continuous improvement and a team focused on that. So don't go in there expecting, they're not hiring you expecting you to be Tony Stark. Okay? Take a deep breath, take it in stride.
Put that on your placement resume.
No billionaire, but looking for a job anyway.
Basically, don't go in there thinking, that you're gonna solve all their problems in a 6-month period of time. There's people who are there's engineers that may have worked there for 20-something years that still haven't been able to solve certain issues. So take what you learn, the experiences that you build from other people, all those things, and apply them. Engineers have resources, and resources are infinite. So they're not going to say it's not like it's not like the school environment where you can use your notes, but you can't use the internet. You have resources, and they're out there. You just got to pick one.
Well, I would assume work's not like school, where you don't have access to your book no more.
Right.
If you need into your book, they're going to be like, go ahead, solve the problem.
Right. And a lot of times they're not going to sit there and say, here's the problem. You got an hour to solve it. If you don't get an F, it's not like that. It's very different. So when you go on these internships, take yourself out of school mode and go back into real life mode. Definitely, you'll find it very beneficial. Any other questions? Bo Stevenson.
All right. Well, thank you very much. You're
welcome.
Yeah, that was.
If you guys have
very
any other questions, you see me around here, say, got a question about internships or whatever,
All right.
happy to answer.